Understand. Rational expressions. Rational means fractions. That's what we've been talking about.
Oh my God.
So lots of fractions, lots of factoring. Factoring, quadratics as well, special patterns, all types, GCFs. But before we get to this, I want to go over one little thing with you.
Who was saying frac? Where is it?
5x y over 10y. Okay? If I am simplifying this, because I'm doing nothing but multiplying, then if you have it in the top and the bottom, it can cancel out, right? I can rewrite 10, if I do it in like a prime factorization, as 2 times 5 times y.
Now, why would you want to do that?
Because there's a 5 up top, so I could cancel them. You know it as reducing the fraction 5/10 to 1/2, but just so you see, so the whole point that I'm getting at here is if it's in the top and the bottom, and you are multiplying, you can cross out, cancel out, crank out, cancel out. Yes?
Yes.
So let's take that a step further then. Let's say I have x plus 3, x minus 2 over x minus 2. Am I still multiplying up top? Yes, because the parentheses indicate multiplication, right? So it's this chunk times this chunk divided by that chunk. So because 2 of those chunks are the same, those can cancel out. Now, am I going to give it to you in this form? No, because that's already factored out. Okay, so here's what we're going to do. The key to this is factoring. Simplifying.
Easy fraction or the quadratic formula?
Rational. Factoring, not solving. We're not setting equal to 0 and solving. We're just factoring. So, the key is factor everything. So, for example, if I have x squared minus 2x minus 15 divided by x squared minus 9, and I'm asked to simplify. I want to factor any and everything that I can before I start. So look at the top. Can I factor the numerator there? Is that factorable? Somebody tell me.
Yes.
Somebody? Yes. 5 and 3. Which one's positive? Which one's negative?
Negative 5 and 3.
Negative 5, positive 3. If you need to put this in the box, put it in the box, but there is no leading coefficient. So whatever multiplies to negative 15 and adds to negative 2 are the two factors that you use.
That air is really cold and I'm freezing, and I've been in Florida all weekend at like 90 degrees and I'm shivering.
It'll cut off in just a second. Okay, look at the bottom. Look at the bottom. Does it factor? Does it factor, Ben?
Yes, it did.
How does it factor?
You gotta put that sucker in sport and do x minus, and then you can do the 2 3s. It's like
yes, you're right. Actually.
Yeah,
Okay, the bottom. Ben,
X
continue. X what?
3 x plus 3
No.
minus 3.
There you go. Difference of 2 squares. We got to remember all those nice special patterns. So now that I'm multiplied, nothing but multiplying, right? Then I can cancel anything in the top and the bottom. So what cancels here?
X plus 3 and x plus 3.
So how does it simplify?
X minus 2.
Can I cancel the x's out since it's in the top and the bottom?
Yes.
No, I'm adding or subtracting. Listen, because this is the key.
Wait, so you can only do the multiplication?
Here's the key. Every plus or minus sign needs to be included in parentheses. Okay, see when we started here, every plus or minus sign was in the middle of parentheses. We could cancel out there. Here, it's not, so we can't cancel out.
Yes,
All right,
ma'am.
we're adding or subtracting, not multiplying. It only works when you multiply. Let's do one more before we do multiplying. That's the answer. It's just simplifying. Can you simplify it? Ben, up front. No, I mean eyes up front, not from up front. Let's do this one. I want you to simplify this. Try it on your own. See if you can get it. 3x squared plus 6x plus 5. All right. Look at the top. Does it have a GCF?
Yes.
2x. When you take 2x out, what's left?
X plus 5.
Looking at the denominator there, same signs. I need two terms that multiply to 15x squared but add to 6.
Three.
Nothing.
I wrote it wrong.
Oh.
Sorry, I apologize. Okay, I forgot the 1 in front of the 6. Oh my gosh. Okay, now can you factor it? Yes. What are the two
15
factors?
and 1.
No wonder y'all were struggling. 15 and 1. I do apologize. All right, so what does it look like factored up and over? What's GCF? What's the GCF?
5.
5. How about here?
3x.
3x, and here
5.
I got x plus 5, 3x plus 1, and now I'm ready to cancel out. Ben.
That's not hard.
All right, so this is simplifying. So simplifying is what we're going to use every time we multiply, divide, add, subtract. After we're done, we take the answer and we simplify it.
I'm good at simplifying.
So let's talk about multiplying. You don't have to. It doesn't matter. If there's just one, you can leave them or take them off. It doesn't matter. All right, let's multiply. Ben?
Wait, so if that were
Yes.
if that were like 6x over 3x plus 1, would it just go to 2 over 1?
If it were 6x over 3x plus 1. No, you can't simplify because this technically is a term on its own. So you can't simplify those that way.
Miss McGee, have you got
Yes.
these new Doritos?
Ben. Multiplying rational expressions. So again, let me just refresh you if we're multiplying, because rationals are fractions. If we're multiplying fractions, any fractions, let's say 2/3 times 1/5. When you multiply fractions, what do you do?
Across.
Across, right? We just do straight across. So it's 2 over 15. All right. So now we're talking about rational expressions. So maybe I have something like, let's say I have, let me go to another page so we got enough room. 8x cubed y over, this is going to remind you a lot of your exponent properties, actually. We'll do it this way, then we'll do it with one that has to be factored.
Subtract of exponents. Please, Matthew.
Straight across, right?
Yeah, I tore my shoulder.
Straight across, Ben, up front, straight across, yes? Now, when I get to this point, a lot of times, I'll go ahead and look at some of my whole numbers here. In other words, 8 divided by 4, I make this one big fraction like this. 8 divided by 4 can reduce. That would be 2 over 1. And then 2 over 2 cancels. Right? So up top, I have how many x's? 7x to the 7th. How many y's?
3.
8 divided by 4 is 2. And then the 2's cancel top and bottom. How many x's on the bottom? 1. How many y's? 3. Now, Ben, is when you subtract it. You said subtract earlier. So, x's. Or what, I mean, there's no right or wrong. Again, this is exponent properties, kind of a review here. You could have subtracted here. And then went across. How many x's, guys? 6. How many y's? 1, because I subtract. Okay, that's a little bit of a review. So we're going to take some of those same kind of concepts and we're going to use them with some polynomials here. Here we go. Here's where it's, guys, I hate that I'm having to beg you to pay attention because you need to know how to do this. First fraction, second fraction. Again, when I told you the key was factoring, that's still the key now. I always want to factor. Let your first step always factor first. Let that be the first step you do every single time. So before I do anything with these two fractions, what I want to do is go ahead and see if I can't factor every piece of them first. So looking at the top of the first fraction, take a 3x out, right? What's left when you take 3x out? 1 minus x. How about the bottom there? That's a 1 leading coefficient, so it should be an easy factor for you if it factors. Does it? Does anything multiply to -5 but add to 4 with different signs? Yes. What? 5 and -1. I got to make sure it adds to +4. Yes? Moving on to the second fraction. Then again, my leading coefficient is 1. That makes it an easy factor. Opposite signs. Does anything multiply to -20 but add to +1? -4 and +5. Remember, this only works because my leading coefficient is 1 on both of these. Then I have over 3x. Now I have everything Banks ready to multiply straight across. And you can cancel. Absolutely. I don't rewrite this as one fraction because I'm a little too lazy for that. I make it one big fraction as it sits, and I start canceling out. The 3x's, top and bottom, gone. Okay, now notice all my plus or minuses are enclosed in parentheses. That's what lets me start canceling, okay? X plus 5. Huh?
You just made one division sign.
A division sign? Well, I made it all one big fraction. What'd you ask, Olivia? It goes, would it what now? Yes, it's left up there. So what I have left, guys, I'm going to show you what I'm going to do with that in just a minute. Right now, this is what I have left. Do we all agree?
Oh, so you can't cancel the little.
Here's what I'm going to do. A lot of you are seeing the 1 minus x and the x minus 1, and you're wanting to cancel them out. Yes. And you're right that there's a very close relationship there. What is the relationship between 1 minus x and x minus 1?
Ooh, they're different because they're swapped.
Why are they different? They are swapped, but look at them as far as the signs go.
Because one's negative, so you can't.
The signs are completely opposite. Do you agree?
Yes.
So what if I said, okay, I'm going to factor out a -1 from 1 minus x. That's going to make the 1 negative. That's going to make the x positive.
Ooh.
Now are they the same? Is -1 plus x the same thing as x minus 1? Is that the same thing? Yes, that is the same thing. Addition is commutative. I can do it in any order. So yes, that is absolutely the same. So I can cancel those out. Banks, take that off your head and pay attention, please.
Well, then technically, you have to write the negative.
And I'm ready. I'm done. Say again. Everybody wanted to cancel the 1 minus x and the x minus 1 out because we saw the relationship. The relationship is both of the signs are different. This one's positive, this one's negative. If they're completely opposite signs like that, yes, you'll want to take a negative one out.
Because they're all different conditions.
Well, okay, the one is negative on the bottom one. And
Okay, one more. Let's do 20x minus 5x squared over x squared minus x
Can I solve it
times
on the board?
x squared plus 3x minus 4 over x squared minus 16. You try this one, everybody try.
So what?
As Ben's working that over here, oh, I mean over there, I'm gonna, come on. Keep going, Ben.
I was checking the. And that's what I was thinking.
Make sure your factoring matches with my factoring.
You want them to have to be X? This is hard and you haven't done it in a long time.
Okay, so the 5x is 5 times x, so technically it's 2 pieces like this. So when you cross it out, you only cross the x's out and leave the 5 up there. So it's 5, and then you've got 4 minus x over x minus 4. And you pull negative 1 out because they're the same, but the signs are switched. So I've got, and I'm just going to make this negative 5 because negative 1 times 5 is negative 5. If I change all the signs inside, I get negative 4 plus x, which is exactly what's on the bottom.
And Miss McGee, do I have to get this?
And I reduce down to just a negative 5. Nice simplifying there.
What can I do for this one? Do I have to
Difference
this
of
one?
2 squares.
So I just do like
So x minus 4. All right, let's talk quickly about division, and we're done. Okay. Tell me this. If I have 2/3 divided by, we'll use the same numbers, 1/5. I don't ever divide by a fraction. Instead, what do I do? So my division problem is theoretically a multiplication problem. So what we want to do is we want to always change it to multiply and flip it. So essentially, it's nothing new with division, only that I'm flipping over the one that follows the division sign. So let me show you. Let's do a cube, one that we have to do a cube pattern on. Y'all got that? Let's say that I have x plus 2 over x cubed minus 27 divided by x squared plus 3x plus 9. I have a fraction. I do not want to divide it. What'd you say? Put it over 1 and flip it. You're absolutely right, Tashawn. Good job. So I'm going to flip.
Can we just divide it for off this one? Okay.
Oh, man.
You guys wrong.
That's okay. Nothing's going to cancel. I meant this was, yeah, okay. How do you factor this?
Oh, it's x plus 9x minus 9x.
Ah. So difference of 2 cubes, which means what I'm going to do, same change plus. Do y'all remember this pattern?
No, I do not remember change plus. I remember saying change.
Remember where we do little parenthesis, big parenthesis, same change plus?
Yeah, but I don't remember.
It's that pattern that you just have to memorize. We take the first one and we square it. We square the last one, then we put the two together. So in this case, I would start looking for what cancels. Nothing here cancels. The two bottom pieces, now you see, I really wanted to write it where that trinomial was on top whenever I flipped it so that they would cancel. But that's okay because we can still do x plus 2 over x minus 3. And all I'm going to do, instead of writing this twice, I'm just going to square it right there. And I can't mark anything out there. I leave it as is. That's it. Let me do one with you that cancels some things out. I know y'all think y'all have to leave when the bell rings, but I'm going to finish this last example. I'm going to finish this last example, Ben. 6x squared plus x minus 15 divided by 4x squared divided by 3x squared plus 5x. As Tyshawn says, put it over 1 before you flip it.
Yes.
And start factoring everything that you can.
Everybody vote for me in denial.
Ben, how about math?
Oh, and Anna for class rep.
This is, guys, when you multiply, what's 6 times 15?
6 times 15 is 136.
Are you running against anybody?
Nah.
Matthew, Ben, I'll wait on y'all. When y'all are done, two numbers, opposite signs that multiply to negative 90 but add to positive 1, what are they? Come on, this is easy. 10 and 9. 10x, negative 9x, up and over. What's the GCF here? 2x. How about here?
3.
Negative 3. How about here?
3x.
3x. How about here?
5.
5. So up top, I factor as 2x minus 3 times 3x plus 5. I'm going to flip this second one over. Can I take anything out? X, what's left? 3x plus 5. So now I'm going to start. I know y'all are not packing up before while I'm still teaching, right?
No, I'm just putting my I just put my calculator in.
I mean, y'all have like put notebooks away and you're... Apparently this is not priority for you guys. Okay, so now I'm going to cancel out the terms that need to cancel out. 3x plus 5. So up top I have 2x minus 3 over 4x cubed.